Hi everyone, and welcome back to Tech Solver Hub. Welcome to this new episode on the history of artificial intelligence. Today, we'll focus on two key topics, expert systems and neural networks. We'll explore how these technologies have shaped modern AI development. Expert systems were among the first practical approaches to artificial intelligence. Based on predefined rules and logic, they simulated human decision-making in specific contexts. A famous example is the MYCIN system, used for diagnosing infectious diseases. However, they lacked autonomous learning capabilities. In the 1980s, expert systems coexisted with the early neural networks. Over time, they lost popularity as more advanced technologies, like neural networks, emerged, which we'll cover in the next slide. Artificial neurons are the foundation of neural networks. Inspired by biological neurons, they work similarly. Just as human neurons process signals through synapses, artificial neurons combine numerical inputs with weights and transform them into outputs using a mathematical function. This similarity allows us to replicate, in a simplified way, biological learning. Let's look at a diagram of an artificial neuron. Each input is associated with a weight that determines its importance. The weighted inputs are summed and transformed by an activation function. This process enables the neuron to learn and improve outcomes by adjusting the weights. Neural networks are mathematical models inspired by the human brain's functionality. They consist of three main components. Input layer, which receives the initial data. Hidden layers, which process and refine the information. Output layer, which provides the final result. Each node contributes to transforming the data, simulating a form of learning. Backpropagation is the process that allows neural networks to learn from their mistakes. During the forward pass, the network calculates the output based on the inputs. Next, the error is calculated as the difference between the predicted and actual outputs. During the backward pass, the error is propagated back to update the weights and improve the network's accuracy. To better understand how neural networks work, we can use interactive tools. One such tool is the Code.org AI Lab, which allows you to explore AI learning in a simple and educational way. You can see how artificial intelligence classifies objects and learns from data. I encourage you to try it out for yourself. Exploring these tools is a fun way to grasp the concepts we've discussed so far. Another valuable tool is TensorFlow Playground, which lets you simulate neural network learning. You can adjust parameters like weights and learning rate to observe how the network's nodes and layers influence the results. I encourage you to try it yourself at. Discover how neural networks work with just a few clicks. This presentation is based on reliable sources and dedicated tools, including the University of Urbino MOOC, Code.org AI Lab and TensorFlow Playground for practical examples. Graphics specifically created for this presentation. And, of course, Wikipedia, which provided valuable historical and conceptual insights. Thank you for watching. If you have any questions or want to explore a specific topic further, let me know in the comments below. I'd also love to hear your thoughts about the tools we've discussed. Did you find them useful? How do you see AI shaping our future? Thank you for watching this episode. If you enjoyed it, don't forget to like the video, subscribe to the channel, and turn on notifications to stay updated on future episodes. Together, let's continue exploring the fascinating world of artificial intelligence.